Hello there. Today we'll be doing search rotated sorted array. In this particular problem, we are given a list of numbers that are in sorted order, but we have a small caveat where we will rotate the array in a certain point in time. We don't know where, but it is rotated. And we need to do this, find a target in O of log n time, which basically means we have to do binary sort and nothing else. So in this particular problem, let's run through it and see how we can solve it. So the first thing to do is to check use left and right pointer and use all numbers because we know that everything is within bound when we first search for a target. So our target right now is 0. And our number that we find is going to be nums mid, which is going to be 6 minus 0 divided by 2, which is 3. So mid is right here. Mid is going to be 7, and that is not equal to the target, but how do we know that we're within bound? So what we do is check if it's in ascending order right now between left and mid. If it is in ascending order, that means we can check whether or not it is in this half of the items. If it is not in ascending order, then it must be in ascending order on the other half, because no matter where you are, it has to be ascending order in some half of the array. So suppose it is not ascending order in this side. It is in ascending order on this side. So let's get to it. So first, check ascending order. So now what we do is we check the numbers. Oh, it's not. It's from is it less than 4? Well, it looks like it's less than 4 because we're target 0. Is it more than 7? Well, is our target more than 7? No, but it's less than 4, so it must not be here anymore. So now we move left to be mid plus 1. So we check the middle again between the two. 6 plus 4 is 10. 10 divided by 2 is 5. Okay, so look, we have mid here. And we check it's currently 1, so basically we have to check again. So left to mid is going to be within bounds, ascending order, and we found the item. It's less than or equal to this item, and it is. So basically we have to move right minus 1 because it is within bound, and we check the middle, and we found the item at 0, and that's how we solve the problem. Between smallest and largest item in bound. That's it, and isolate the target. Otherwise, return 0. All right, let's do it. So left and right, pretty simple. Right equals 0, left equals length of nums minus 1. Perfect. And while left is less than or equal to right, we're gonna check find the mid. Mid equals left plus right, divide by 2. Alright, now what we're going to do is get the number. So if nums mid is equal to target, let's return the mid. We found it. Otherwise, if nums of L is less than or equal to nums of mid, then we are within the increasing order between left and right. So we can check if the nums L, if the target is smaller than nums L, or if the target is greater than nums M. That means it can't be within this boundary of ascending order. It must be in the other side. So left equals mid plus 1. Otherwise, it is within bound, so R minus equals 1. So it moves within bound. Else, if we want to be clear, so let's be more clear and let's write out this code. So otherwise, the nums mid is less than or equal to nums of right, and that's in ascending order. So if that's in ascending order, if target is less than nums of mid, or target is greater than nums of right, that means it's not within this side of the items, so R equals mid minus 1. No, wait. Yeah, r equals mid minus 1. Because it's not within this order. Else, it is within the item, so left equals mid plus 1. All is good, and if we don't find anything, let's return -1, and we're all good to go. That's all this is, and it's once you have the problem in your brain, well, mid ho ho. So I think mid is not the greatest item here because we should use shorter items because this does not auto finish, and so we should use mid as m because we have to type this so many times, and that means that we will be making typos. So we're gonna reduce this, make this shorter to just m so that we don't have these typos. Unless we had autocomplete, but we don't. So let's just get m in here. Another way to do this, I see, is to use number equals nums m, but however, that it poses a problem because it confuses us and tells us, oh look, nums m's is something special, but it's nothing special. We're trying to tell the reader that it is the midpoint, and we're looking at the midpoint. This is very important. Let's look at the midpoint. Let's look at the left side. Let's look at the right side. Let's make sure it's in ascending order. So that's why it's important. So check left to right is mid is ascending order, and this is checks mid to right is in ascending order. This checks, you know, in bound of mid to right, and this checks in bound of left to mid, right? So this is very important. I think this gives us a lot of information about what's happening here and what this binary. This gives us so much information about binary search without even telling us if we've seen this problem. But I think comments are important, and the video is spectacularly important, I think, because I'm making it. No, not really, because it goes through the process of how we come to the answer of this particular problem. And so I think the video helps separate out how we can come to the answer, not just seeing the whole answer at the same time, which makes it more difficult to parse out. So, and that's it. And this does run in 41 milliseconds, which is 90 percentile of the Neetcode. It's just sometimes it's 41, 64, 51. And that's how we do this particular problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.